Today we're going to be graphing systems of linear equations. And when you graph systems of linear equations, we know we're going to have to look at where do these two lines intersect. So we're solving for the point where they cross. So in order to do that, we are going to have to find the slope and the y-intercept of each individual equation. So that's kind of where this picture comes into play, thinking about slope. And if I get a steep slope, in my case, especially the steeper the slope, the faster I end up on the ground. All right, anytime I'm thinking about graphing, we're always thinking about kind of getting into the slope-intercept form. That's generally the easiest way to graph. And here I know that we know m represents, that's our slope, right? Or technically it's just whatever is in front of the x once I have it set up as y equals. Well, these are already set up as y equals. So here, I want to do my slope. Now, I always say to always make slope, always make sure slope is written as a fraction, regardless of whether it looks like a fraction or not. Always write it as a fraction. Here in the equation 1 is what's in front of the x, right? So here my slope is -1/2. Our y-intercept is always what's going to be at that's our b, right? What comes at the end. So y-intercept here is -4. So now I can actually start graphing. When we start graphing, always start from the y-intercept. So I go to where it crosses the y-axis, and I'm going to go at -4. And since it has a slope of -1, I know I'm going to do then rise over run for slope, right? So the rise is -1. So I'm going to go down 1 and over 2. So down 1 over 2, and I have my next point. And then I can do this the reverse and go up 1 and over 2, and I have this point. So it looked like that. For this other one, so equation 2, I want to do the same thing. What is the slope? Now the slope here is 3, but once again, don't ever just write 3. Write it as a fraction. So 3, if there's nothing underneath it, put the 1. So I know it's 3 over 1. And the y-intercept is 3. So now I can go up to 3. And it says it goes up 3, 1, 2, and then go up to 6 and over 1. So up here. And then I go the reverse. Down 1, 2, 3, and over 1. 1, 2, 3, and over 1. And so I get those points. And so that's my line there. So what am I looking for whenever we're solving these graphically? We are looking for where do they actually intersect? Where do they cross? So what is the value of this point? Our x is at, so the solution here is -2 for x, and the y value is -3. So that would be the answer. X is -2, y is -3. All right, what I want you to do now at this point is actually pause it and see if you can figure out all of these pieces on your own. We know y-intercept is -1. I know the slope, if I go down 1 and over 1, or up 1 over 1, 1 over 1, 1 over 1, down 1 over 1. So there's my line there. And so it looks like that. And for the other one, I have a y-intercept of 2. And it says I go up 1 over 2 and go reverse, down 1 over 2, down 1 over 2. And there's my line there. And so where do they actually intersect? We know we want to put it in x comes first. So the x value of the intersect is at -2. The y value is at 1. And there is our solution there. Right, once we see these type of problems, we do have to rewrite them in terms and solve for y. So I want to get y by itself. So let's look at equation 1 here. I have 5x minus 3y equals -6. And how do I get this y by itself? And what I usually do is tell my students to isolate the equal sign so I know I don't mess up there. So I know I want to get everything away from the y and across this line to the other side of the equal sign. So I need to somehow move this 5x group over there, and so I know I need to do opposite operation and subtract 5x, subtract 5x. And so when I do that, I get a -3y that drops down. And I can't add those together, so don't make the mistake of doing that. X and a number don't add together, not like. So therefore, I'm just going to write the X term first and put the number second, just so it looks like Y equals mx plus b, X then the number. And now I got to divide, get rid of this -3, so I'm going to divide everything by -3. So divide everything by -3, so I get Y equals, and what do I get here? -5 divide by -3. -5 divide by -3. Just leave it alone, but the negatives cancel. So I get 5 over 3x, and -6 divided by -3 is a +2. And so for equation 1, we can easily identify now our slope is 5 over 3 and our y-intercept is 2. So here for the second equation, taking the same thing, x plus 3y equals -12. I want to move the x over across the equal sign, across this barrier, right? Get it away from the y. So I need -x doing opposite operation. And so that cancels out. So the 3y simply drops down and falls out. -12, -x don't combine. So -x and a -12, just put them together. And now I got to get rid of the 3. So I have to divide, and we got to do it to everybody. So I'm dividing that all out. And so now I get y equals, and what's in front of this x we know is a 1, right? Because there's a understood 1 with all x's if there's no other number there. The 3 is a denominator, so don't make the mistake of putting the 3 next to the x. It's a denominator. -12 divided by 3 is -4. So now I can go ahead and say, well, what is the slope and what is the equation for equation 2? Well, we know that has a y-intercept of -4 and a slope of -1/3. So now I can go ahead and graph those pieces out. So if start with the y-intercept, if my y-intercept is 2, I know it's going to go up 5 and over 3, 1, 2, 3. That's going to kind of go off the screen, up 5 and over 3. So it'd be somewhere like up way over here. And I do the reverse, go down 5, 1, 2, 3, 4, 5, and over 3, 1, 2, 3, and put my point. And now I can draw my line between and connect my points, right? Then I can do the exact same thing for the second equation. We know it has a y-intercept -4, go down 1 and over 3, and do the reverse, go up 1 and to the left 3, and so I get that point, and so I can draw that line through those points, and so that's going to look something like that. And we can see the point of intersection easily and clearly, right? It's that point right there, which has got to be x value of -3, y value of -3, and we're done. All right, at this point, try to pause the video, see if you can work this one out completely and make it look like what I end up getting. So pause, try the problem, and if you're stuck, then just watch the solution. 4, so I can put my y-intercept of -4. I can go up 2, 1, 2, and to the right 1. Reverse, go down 2, 1, 2, and to the right 1, and then make my line. So I know my line looks like that in that case. And we're going to do the exact same thing. So I can go at my y, so go up to my y-intercept starting at 4. And then I got to do the slope. It says -2 over 3, so I'm going to go down 2, 1, 2, over 3, 1, 2, 3. Go down 2, 1, 2, over 3, 1, 2, and this would be over there. And so I can make my line that looks like that. And there I can see the point of intersection now is also fairly clear right there. So I know the x value is at 3, the y value is at 2, and there is my solution. So here, if I want to graph this out, I know, let's take equation 1, 2x minus y equals 2. I want to isolate the y, so I got to subtract 2x from both sides. And so I get -y equals -2x and a +2. And I got to somehow get rid of that negative, right? So, and I get y equals then 2x. And remember, we want to always make that slope a fraction, and 2 divided by -1 changes the sign to -2. So I know my slope there is 2 over 1, and I know that the y-intercept is at -2. All right, let's do the exact same thing for the second equation and figure out what that is. So I got 2x minus 3y equals -6. And I want to, so we need to isolate the y. So move the 2x across the equal sign. And that cancels that. So I get minus 3y. I have a -2x and a -6. Well, I need to get rid of that -3, so it's multiplied in this scenario, so we divide. So divide everything by -3, and I get y equals 2/3 x, and -6 divided by -3 is +2. So now I know my slope is 2 over 3, and I know my y-intercept is 2. So slope of 2 over 1, y-intercept of -2, start at the y-intercept. What is the slope? Rise of 2, run of 1. So rise of 2, go up 1, go up 2, go over to the right 1, and there is my point. Do the same thing, up 2, over 1. And I could go reverse, down 2, over 1, and draw the line. So we know our line looks like that. And now I can do this other equation and draw that out. So I know that it starts at a y-intercept of 2. I know that it has a slope of 2 over 3, so it goes up 2 over 3, 1, 2, 3. Goes down to 1, 2, and over 3. So it looks like that guy. And so I know that there's my line there. And we can see then the point of intersection has to be that point right there, which is going to be at x equals 3 and y equals 4. And we are done with that. Now let's check that algebraically and see how that plays out. Did we get the same solution? Right. This type of problem is already set up for what I call elimination. So if x and y are already on the same side, we can go ahead and eliminate. So we want to try to, in elimination, you want to try to what? Get rid. So we want to get rid of some variable. How do I get rid of that one of the variables? I need to make them the same somehow. Well, here I can see x's are already the same value. They're both 2's. So what would happen if I subtracted these, I could then get rid of the x's, because 2x minus 2x goes to 0. So we want to get rid or make something go to 0, go away. One of the variables. We want to either get rid of x or we want to get rid of y. So in this case, we said x was the easy one, so we're subtracting these out. So if I subtract these two equations, 2x minus 2x, the x goes away, so we don't have any x. If I subtract these two equations, negative y, so remember, so it's like -1 minus a -3. So if I do -1 minus a -3. Well, minus a minus, anytime you see two negatives side by side, I always think plus. Two negatives make a plus. That's how you make a plus sign, right? A plus sign is made by a dash and a dash. So two dashes side by side make a plus. So -1 plus 3 then becomes 2y. And if I subtract this, 2 minus a -6. So we're doing 2 minus a -6. Once again, two dashes side by side make a plus. So this would be 8. So now I can easily solve. Y is, so if I divide by 2, y is equal to 4. Is that what we got? Yes, we got y of 4 on our graphing. So now that I know that y is 4, I'm going to just plug it into one of the equations that I had. So I had 2x, original equation, 2x minus y equals 2. Doesn't matter which you pick. I personally like to pick the easiest one of the two to plug into. So I'm going to plug the 4 in place of y, because that's what y is equal to. So I got 2x minus 4 equals 2. And now I can solve. So I'm going to move the 4 over across from the x, which is what I'm trying to solve for. So add 4, So I got 2x equals 6, divide by 2, and x is equal to 3. Is that what we got for x? Absolutely. So we can do it graphically or algebraically. They are the same exact process. We're finding the same answers.